Yaragula Anthony, ನಾನು ನಿಮ್ಮ ಮ್ಯಾಥಮೆಟಿಕ್ಸ್ ಲೆಕ್ಚರರ್. ಸೊ ಇವತ್ತು ಸೆಟ್ಸ್ ಮೇಲೆ ಥರ್ಡ್ ಕ್ಲಾಸ್ ಆಗಿದೆ, ಮೂರನೇ ವಿಡಿಯೋ ಆಗಿದೆ. ಸೊ ಇವತ್ತು ನಾವು ಟೈಪ್ಸ್ ಆಫ್ ಸೆಟ್ಸ್ ಬಗ್ಗೆ ಡಿಸ್ಕಸ್ ಮಾಡೋಣ. So today let us discuss about types of sets. So on the board I have written some types of sets. Not only these, there are other types of sets are also there. But today for this video, let us be confined to only these many number of sets. Okay. So in the next class, in the next video, I'll be discussing with you all about other type of sets. Okay. So let us begin the class. So the names which I have written on the board here, they go like this. Empty set, this is one type of set. Singleton set, finite set, infinite set, equal sets, equivalent sets. Okay, so let us begin learning this one by one. Okay, so here first let us start studying what is empty set. So here empty set, the name says empty set. Okay, this is the first set, empty set. As the name says, empty, it is also called as, some textbooks they name this as null set also, and in some textbooks they name this as void set. Void set. So empty set, null set or void set, all the names may be different but all are saying the same thing. Okay, overall what is this empty set, what is this null set, or what is this void set? See, a set with no elements, a set with no elements is called as empty set. So clearly we see no elements. That's what the speciality of this set is. So it is the set which does not have elements in the braces. Okay, so the cardinality of this set will be 0. You know what is a cardinality? Cardinality means the number of elements in the set. Okay, see, even cardinality is also sometimes called as the size of the set. See, cardinality or size of the sets, both are same. Cardinality or size of the set. Okay, so cardinality means number of elements in the set. Even the size of the set is also number of elements in the set. So an empty set will not have any elements in its braces. That is why the cardinality or the size of the set will be 0. Okay, so suppose if I want to write an empty set, so how I am going to denote that empty set is like this. See, we can denote it by just writing the empty braces like this, or we can use a symbol like this, that is phi. Okay, so these are the two notations, and let me say you, these are the only two notations to represent the empty set. Okay, so you can either write just the empty braces or you can write phi. You cannot write together again. That means writing this way again, it is not empty set. So if you want to write an empty set, you have to just write the empty bracket or the phi symbol. Okay, so now these are the two symbols which are going to denote the empty set. Now I will give you one example so that you will understand whether there is an empty set or there or not. Okay, whether there is an empty set or not. Okay, now see example. A is equal to set of natural numbers less than 1. Okay. So A is the set of natural numbers less than 1. So we know that there is no natural number less than 1. Why? Because the natural number starts from 1. So there is no natural number which is less than 1. So that means the roster form of this set is just an empty set. We cannot write any elements inside the braces because there is no natural number less than 1. Okay, now the cardinality or the size of the set of A, we denote like this: n of A is equals to, there is no element in this, that is why it is 0. Okay, so in other way, if the cardinality of any set is 0, we can easily call that set as a empty set. Okay, so an empty set is even called as a null set or a void set. Now this is the definition and this is the explanation about empty set. Now let us see the second type of set which we have written. Okay, the second type of set, that is Singleton set. Singleton set, as the name suggests, a set with only one element is called a Singleton set. Okay, so a set with only, that's what we see here, only one element, such a set will be called as a Singleton set. Okay, so an example if I give you, A is the set of even prime numbers. Set of even prime numbers. Okay, that means there is only one such prime number, that is 2. So in the prime numbers there is no even number, isn't it? Only the prime number which is even number is, that is the 2. So this is a perfect example for a Singleton set. Okay, so a set with one element or one member is called as a Singleton set. Yes, the cardinality of this Singleton set, that is n of A, is equal to 1 because there is only one element in this. So the cardinality or the size of this set will be equal to 1, isn't it? So why? Because there is only one element in it. So a set with only one element is called as a Singleton set. Okay, now let us go to the third definition or the third type of set. Let us go to the third type of set, that is, as we have written in the list, finite set. Finite set. Okay, so here we see the word finite. That means a set with finite number of elements. is called a finite set. Okay, so the main speciality of this set is it will be having finite number of elements. That means we can know easily how many elements will be there in this set. Okay, we will be knowing whether there is 2 elements in this set, 5 elements are there in this set, or 10 elements are there in this set. Okay, maybe 100 elements are there in this set. Okay, so if we know how many elements are there in that set particularly, then that set is called as a finite set. Okay, if you know the number of elements in that set, then that set is called as a finite set. Say for example, if I give you A is equals to set of colors in rainbow. Now this is a finite set. Why? Because you know in a rainbow there will be how many colors, right? So there is nothing hidden to you all. So you know very specifically how many colors will be there in the rainbow. So that is why you know the number of colors in the rainbow. That is why it is called as a finite set. Okay, it is called as a finite set. Now if I want to give you another example, set of students in a classroom. Okay, so now if I talk about a particular class, say for example PUC first year or a PUC second year, class A division, something like that, we know how many students will be there in that classroom. So we know the number of students in that classroom. So when we know the number particularly, then we can understand, we can say that it is the finite set. Okay, so the cardinality of this set will be n of a, which is equal to, if I just take it as a generally small a. Now this small a represents that end number what you know. For example, in the case of a rainbow, you know what is the end number. Okay, in the case of a students in the classroom, you will be knowing what is the end number. So that end number is this small a. So one thing we need to always understand here is, see, the definition says the finite number, and when we know how many elements are there in the set, then it is called as a finite set. In that case, now empty set is also a finite set, because we know that there are 0 elements in that set. See, we came to know that there are 0 elements in that set. That is why even empty set is called as a finite set. And surely Singleton set is also finite set, because we know there is 1 element in that set, and when we know how many elements are there in a set, we can easily say that it is a finite set. Okay, now the next definition we are going to see here is about infinite set. Okay, let us see what is infinite set. The definition number 4. Infinite set. So it is the very opposite to that of the finite. That means if a set is not having the finite number of elements, if the set is not having the finite number of elements, then it is infinite set. Okay, a set which is not finite, that means is called as infinite set. Okay, so that means if you don't know particularly how many elements are there in that set, so if you cannot answer that, if you don't know that the particular set is having so many elements and all. So in that case, you are going to call it as a infinite set. So please don't mistake me when I say if you don't know. It's not like that. It's we should be knowing or not knowing. So it's in general. If I'm speaking, for example, set of natural numbers. When I say set of natural numbers, so how many numbers you are able to write now? You should be starting from 1, 2, 3, 4. Where is the end of that numbers now? So when we don't find the end of that numbers, such a set is called as a infinite set. Say for example, set of integers, isn't it? Even integers also, there are endless are there. So even set of integers is also a infinite set, isn't it? So an infinite set means which we will not be able to knowing the end number. So such a set is called as an infinite set, or very simple definition is if the set is not finite, then you can easily take it as an infinite set. Okay. So here usually an infinite set we represent like this. Suppose if I take the first example of natural numbers, so 1, 2, 3, 4 and so on. See, this dots says that we don't know how many elements are there further. So or there is no end for that numbers, right? Such a set will be called as a infinite set. Okay, now tell me, can we write the cardinality of this set now? Yes, so there is no number, right? So we cannot write the cardinality of a infinite set. Okay, if at all we want to write, means we can just write like this: cardinality of an infinite set will be definitely infinity. Okay, or in other way, if at all any set's cardinality or the size of that set is infinity, then we can call it as infinite set. Okay, if the size of any set is infinity, if the cardinal number of any set is infinity, then we can call that type of set as a infinite set. Okay, now let us go to the next type of set, that is called as a equal set. Equal sets. Okay, fifth one, equal sets. Now equal sets, two or more sets are called as equal sets under two conditions. Two conditions must be satisfied to say that two or more sets are equal. What are those two conditions? Is number one is their cardinality must be same. Okay, their cardinality must be same. That is the number one condition to say if any two sets are equal. The second thing is every element of one set, I repeat, every element of one set must be equal to every element of the other set. Okay, now this is the second condition. Every element of one set must be equal to every element of the other set. When these two conditions compulsorily are satisfied, then we can say that the two sets are equal sets. Okay, now let me write here: two or more sets are said to be equal, if their cardinality is the same, and if every element of one set is same as every element of other set. Okay, then these sets are called equal sets. Okay, so two or more sets are said to be equal if the first condition is their cardinality must be same, and second condition is every element of one set is same as the every element of the other set. Okay, every element of one set is same as every element of other set. If these two conditions are satisfied, then we can call that two sets are equal. Okay, I will take one example in order to make you understand. Okay, so follow this example, then you will be understanding this equal sets very easily. Okay, see here, I will take set A is equals to 1, 2, 3. Set B is equals to 2, 3, 1. Set C is equals to 1, 4, 5. Okay, 1, 4, 5. Now, what is the cardinality of all these three sets? Let us first study that one. The cardinality of A is, see, there are three elements in the set, 1, 2, 3. So the cardinality of A is 3. That means the size of this set is 3. Similarly, the cardinality of B is also 1, 2, 3 elements are there. So it is 3. And the cardinality of C is 1, 2, 3. 3 elements are there. So the sizes of all the three sets are same. That means the first condition of equal sets is satisfied. Okay, now can we say that these three sets are equal? Absolutely no, because the second condition also must be satisfied. What is the second condition says? Every element of one set is equal to every element of the other set. Now let us see where this condition is getting satisfied. If I want to check the set A and set B, because their cardinalities are same, so I proceed to check whether A and B are equal or not. Okay, now you can see in one is there in A. Is there one in B? Okay, there is one in B, right? There is 2 in A. Is there 2 in B? Yes, there is 2 in B. Now there is 3 in A. Is there 3 in 1? 3 in B? Yes, there is 3 in B. Okay, even if you see from this side, there will be, so all the other elements. Say for example, now 2 is in B. Is 2 is in A? Yes, it is in A. Isn't it? Now 3 is in B. Is it in A? Yes, it is in A. 1 is in B, and even it is in A. So by this we understand that the every element of A is belonging to every element of A is there in the B, right? That means every element of B is there in A. So that means already, because their cardinalities are same, so first condition was satisfied. Now because the elements are also same, now the second condition is satisfied. So we can clearly say A is equal to B. Now let us see what about B and C. Are they equal? See, their cardinalities are same, but are they elements same? Even if one element is not same, it is not equal. Let us see that one. 2 is in B. Is 2 belonging to C? No. So that means B and C cannot be equal. I said even if one element is not there common in both of them, then they are not equal set. Let us check A and C. Okay, 1 is in A. Is it 1 in C? Okay, 1 is in A and 1 is in C. 2 is in A, but 2 is not there in C. That means even A and C are also not equal. So how to write them? See, B and C were not equal. A and C were also not equal. So even though the cardinalities, the size of the sets may be same, but the second condition must be satisfied for the equal sets. Okay. Yes. Now let us proceed to the next type of sets, that is called as equivalent sets. Equivalent sets. This is the last type for today's class. Okay. Equivalent set. Two or more sets are said to be equivalent if the first condition, their cardinality is same. That means the size of the sets is same. Okay. If their cardinality is same, okay, but elements of one set need not be same as the elements of other set. Okay, so here only if one condition is satisfied, then they are equivalent. What is that condition? Their cardinality is same. If this is satisfied, even though the elements are different, like in the equal sets, elements must be same, but in the equivalent set, if the size of the sets is the same, it is enough. Okay, there is no condition that the elements also must be same. Okay, so such type of sets is called are called as equivalent sets. Okay, now I would like to give one example so that I can make you understand what are equivalent sets. Now see here, I will take A is equals to A, B, C, B is equals to 1, 2, 3, 4, whereas C is equals to 1, 3, 7. Okay. Now before we proceed further, let us find their cardinalities. That means the size of the set A is equal to, there are three elements, 1, 2, 3. So the cardinality of A is 3. The cardinality of B is equal to 1, 2, 3, 4. So then the cardinality of C is equals to 1, 2, 3. So we can clearly see the cardinality of A and the cardinality of C are equal. According to the definition of equivalent sets, if the cardinalities are same, it is enough to say that those two sets are equivalent. So we need not check for the elements. Only the cardinalities are same means it is more than enough, right? So by looking at these answers, we see now A and C are equivalent. Symbolically, we write like this: A is equivalent to C. Now this is the way of representing or showing that A is equivalent to C, whereas the cardinality of B is different from these two, so B is not at all considered. Okay, now this is the symbol of showing that A is equivalent to C. Okay, so now here, now let us end this class here. So these are the 6 definitions of different types of sets which I have given to you. Now you go through these videos again and again and understand them clearly. Okay, so every definition is very important and you need to really understand the types of sets. Still there are more types of sets are there, which we are going to learn in the next videos. Okay, and till then everybody be sincerely writing these all notes in your notebook. Okay, so when you come back to the college, I'll be checking all those notes, and I'll be correcting all those notes. Okay, and once again I thank for all the students who are encouraging me through the comment section. I thank each and everyone. So understand this, and if you have any doubts, my suggestion is, so watch this video again and again. You will never get any doubts. Okay, till then, take care. Bye everybody.
Okay.